Hello, Calc students. Hope everyone is doing well, having a great Christmas day. You know what I mean? So, today we'll be discussing some related rates problems. The one fear that Calc students have this and optimization, which I'll be covering in a later video. But for now, we're hit with the shadow problem. We're given that a 6 feet tall person is walking away from a 15 feet tall street lamp at a speed of 4 feet per second. At what rate is the tip of the shadow moving away from the base of the street lamp? You can pause the video here and try it out on your own, or you can go through it with me. Okay, let's sort of try to visualize this, because that's always the first step when you encounter a related rates problem. So you have here, let's say this is a street lamp right here, whatever this is. This length right here is 15 feet. Now we know that there's a 6 feet tall person. Okay, I wish I was 6 feet. I wish you do too. But yeah, so there's a 6 feet tall person. Let's say right here. Just imagine this guy is just like that. Don't worry about the line in his head, right? And what else are we getting? We're given that he's walking away from the street lamp at a speed of 4 feet per second. Okay, let's actually draw this triangle right here, right? This can maybe sort of give us, this is sort of the shadow that's generated right here, right? So we'll draw this. So we know that this, let's say like this length right here, let's give some variables. This length, let's say is L. Let's say that from this, let's say is S, and this, let's say is X. Now we're given that he moves away from the street lamp at a speed of 4 feet per second. Is that relating to ds dt or dx dt? Well, it's, if you think about it, right, it's actually ds dt because he's moving away from the street lamp. So it's directed towards the street lamp right here. So it's ds dt. So ds dt, as we're given, is 4 feet per second. Okay? So if ds dt is 4 feet per second, what are we trying to find exactly? Because it says what rate is the tip of the shadow moving away from the base. Okay, so we're trying to find, this is the tip of the shadow. So away from the base of the street lamp, well, the street lamp's right here. So what connects this to? This line right here. And what is that? L. So we're trying to find dl dt. So what is dl dt? Well, let's try to find some relationships. So first we know that L, sorry about that. Oh, I don't know what's happening. Okay, so we know that, first of all, we know that L is equal to S plus X. Now let's take the derivative with respect to time for both of these. So it'd be dl dt, right? dl dt is equal to ds dt plus dx dt. Now we're given ds dt, but let's see if we can find dx dt. What can we figure out? What do we see about these two triangles right here? This one, big triangle right here, and this triangle right here. We can see that they're similar triangles because they have the same angle right here. So we can establish a relationship that 15, right? 15, this side over this side is equal to this side over this side, since they're similar triangles. That's part of the definition of a similar triangle. So 15 over s plus x is equal to 6 over x. Now we can just cross multiply to get 15x is equal to 6x plus 6s, distributing the 6. Now this gives us, right here, you can move the 6x to this side. So it'd give us 9x is equal to 6s. We can take the derivative with respect to time. So it'd be 9 times dx dt is equal to 6 times ds dt right here. Now we can substitute that we have the 4 feet per second. So we can plug that in. So it'd be 9 times dx dt is equal to 6 times 4, which we can clearly see that now dx dt is equal to 24, because 6 times 4 is 24, over 9, because you divide by 9 to isolate the dx dt. So now we have dx dt. Is that what we're trying to find? No, we're trying to find dl dt. But what do we know about this relationship right here? We know dx dt, and we know ds dt as well. So all we have to do is plug in. ds dt is 4 plus we're given that dsdt is 4, dxdt is 24 over 9. And we can combine these fractions by setting a common denominator of, let's say, 9. So it'd be 36 plus 24 over 9. Sorry about that. And this comes out to 60 over 9, or 20 over 3 when you simplify it. And this 20 over 3, now think about what is the units for this, right? So we always want to provide units. Well, the units, it says that what rate is the tip of the shadow moving. So it's some unit of distance over some unit of time. So in this case, it'd be feet per second. So that is your answers. This guy, this 6 feet man, I wish I was that man, but this 6 feet man is moving at 20 over 3 feet per second. So there you go. As always, please like, comment, and share, and subscribe for more exclusive content like this regarding calculus. Good luck, guys.